Good morning, girls. I hope you're all fine, all good. And children, in maths, we had started with the chapter Quadrilaterals. And in the exercise 8.1, I had completed with you 4 questions. Now, today I will show you how to solve question number 5 and question number 6. Okay. Now, children, you know that this type of chapter you have not done before. This is completely based on the proofs, theorems, and then applications of those theorems. Okay, so I expect that all of you will practice well and study this chapter very thoroughly so that you know whenever any question is given to you, you can easily solve it. Okay, now starting with question number 5, it says that show if the diagonals of a quadrilateral are equal and they bisect each other at right angles, then it is a square. Okay, so we'll try to understand the question that if the diagonals of the quadrilateral, question number 5, exercise 8.1, okay, and so I will draw a quadrilateral and name it as ABCD. Yes, now it is saying that the given quadrilateral ABCD in which the diagonals are equal. Okay, the diagonals of the quadrilateral are equal at length. They are meeting at O. Okay, so we write AC is equal to BD. This is given. Then it is also given that the diagonals are bisecting each other. So OA is equal to OC. And another part will be OB equals to OD. Then it also says that the diagonals bisect each other at right angles. So these are right angles. Okay. In the center, angle AOB, then angle BOC, this angle and this angle. All are right angle. This is the intersection point O. So we write angle AOB is equal to angle BOC is equal to angle COD and is equal to angle DOA, all equal to 90 degree. Yes, this is given. Now we have to prove that ABCD is a square. Okay. Now when I say that ABCD is a square, it means all the 4 sides of the square should be equal. So we have to prove that AB is equal to BC is equal to CD is equal to DA. Then another property of the square is that the angle should be the right angle. Okay, so if one angle is a right angle, so if I write angle A is equal to angle B is equal to angle C is equal to angle D, 90 degree. So if I prove any one of them to be 90 degree, then all the other angles can be shown that they are all equal to 90 degree. Now to prove that ABCD is a square, we have to first show that ABCD is a parallelogram. You know why? Because square is also one type of parallelogram. So therefore, first we'll prove that the given figure is a parallelogram, and then we will use some congruence condition to show that it is a square. Okay, so as I told you, what we have to prove, that AB is equal to BC is equal to CD is equal to DA. Now let us start with the proof, and I will take up triangle AOB. This question has 3 parts, 3 to 4 parts, children. So let us understand it carefully. Triangle AOB and triangle COD. Okay. First part. We know that in these two triangles, OA is equal to OC, which is given. Yes, I hope you can see. And number 2, OB is equal to OD, which is also given that the diagonals are bisecting each other. And the third point is angle AOB is equal to angle what? COD. Yes, and what is that? 90 degree, because the diagonals are bisecting each other. So therefore, if you compare this, the 2 sides and 1 angle, these 2 sides and 1 angle, you will write the triangles are AOB is congruent to triangle COD by SAS property. Yes, or SAS criterion. Okay. Now, Now, as I told you that we have to prove that ABCD is a parallelogram. So if I somehow prove that the alternate interior angles are equal, then the opposite sides will be parallel. Okay. So now what I'll do, you know that these two triangles are congruent now. So if I take this angle, can you see with the red pen I've marked? Yes. And this angle. Okay. Now another angle which I will take is this one and this one. Okay, so I will now write angle OAB. Angle OAB. Okay, I think this is very light, no problem. Angle OAB is equal to angle OCD. Yes, and we are writing this because they are congruent parts of the corresponding parts of the congruent triangles. Similarly, I will write angle OBA is equal to angle ODA and again CPCT. Now you know that this pair, both the pairs we write, but these are alternate interior angles. Okay, alternate interior angles. Therefore, when the alternate interior angles are equal, children, we can write that this pair of lines are parallel to each other. So therefore now I can write, therefore if I see that CD and AB, they are intersected by this what? Transversal, right? They are intersected by the transversal, and therefore when I 1 minute, AB and CD. So if I take 1 minute, if I take this and this as okay. So now when I take these alternate interior angle pairs, we can write that therefore AB is parallel to CD. Okay, AB is parallel to CD. Now to prove that, children, it is a parallelogram, you know that opposite sides of the parallelogram are equal as well as parallel. So we have to prove similarly this pair is also parallel. Okay, so what we can do, we can write similarly we can prove. Just now I have taken these two triangles. Now to prove that AD is parallel to BC, we have to consider these two triangles. So same type of proof will be written for this another pair also. So we write similarly we can prove that AC is parallel to what? Sorry, not AC, I am sorry. AD is parallel to BC. Okay, so I hope this is clear to you that we first take these two triangles and prove them to be congruent, and then because these are alternate interior angles and they are equal, and therefore these lines are parallel. And similarly for these two we can write that similarly we can prove by the same SES condition that AD is parallel to BC. Okay, so this completes your first part, and okay, now 1 minute, we are still left with we have to prove that all the four sides are equal. Now to prove that all the four sides are equal, we need to prove that AB is equal to BC. Yes. Now one more thing I can add here, children. When the two triangles are congruent, AB is parallel to CD, I can also write that AB is equal to CD. Yeah, because of the CPCT. Similarly for this pair, when I will solve this pair, I can simply write that AD is equal to BC. Okay, now since the opposite sides, we now write since the opposite sides are equal and parallel, therefore ABCD is a parallelogram. Okay, as I told you that first we'll prove that the that ABCD is a parallelogram. Now we have just completed these opposite sides. Now because we have to go for all the four sides, we have to also prove that AB is equal to BC. Okay, and for that I have to consider triangle AOB and BOC. Okay, so I hope this part is clear to you. I will now proceed with the next part. I am rubbing this. So now I will take the next to complete the next part of the proof. I will now write. I hope you can see, children, right? Yeah. I will now take. Now consider. If you want, I can write it in between, but then I have to rub it. Okay. So consider triangle AOB and triangle BOC. Okay. We have to prove that they are congruent. OA is equal to OC. OA is equal to OC. Yes, this is already given. Then OB is a common side. Yes. Now children, you have studied congruence in class 7th. So you have to, even we have done in the previous chapter also, but you have, as you will keep on doing these sums, so you will get a thorough practice of this congruence. And now I think you must be very clear with which congruence conditions we can apply in the given set of questions. And what is the third one we can take? That angle AOB, yes, is equal to angle BOC and equals to what? 90 degree. So can we apply SAS, side, side and angle? So yes, we can write triangle AOB is congruent to triangle BOC by side angle, side congruence. So this is complete with this one. Now I can write AB is equal to BC. Okay, I can now write AB is equal to BC, and what is the reason? CP, CT. Now, next, AB is equal to BC, proved above, means this part. We have proved AB is equal to CD, yes, and we have proved that AD is equal to BC. Okay, now let us consider all the three. AB is equal to BC. So AB is equal to BC and AB is equal to CD. So AB is equal to BC is equal to CD and is equal to AD. Because all the four sides will be equal now when we try to understand this. That one side is equal to another side is equal to the next side, and I hope this part is clear to you. Okay. Now, so we can now write therefore AB, by when we compare the three equations, we now get AB is equal to BC is equal to CD is equal to DA. But that's not enough to prove that it is a square. We have to prove that it is a right angle. These all four angles are right angle. Okay, so for that I will now take triangle ABC and triangle BDC. Okay, triangle ABC and triangle BDC. Not BDC, I will write BCD. I will go in this complete, cyclic order. So we now say that first part, BC is equal to BC common. Yes. Now, this one, ABC, let me highlight it. ABC, this, and BCD. So when you compare these two triangles, children, you will understand that BC is a common side. Then secondly, AC is equal to BD given, because it is saying that the diagonals are equal in length. And the third point is what? We have proved that AB is equal to CD. Yes, and that is proved above. So these reasons are important to write. Okay, now we can write the triangles are congruent by SSS. Okay, so first we had taken these two triangles. We had proved that AB is parallel to CD and AB is equal to CD. Then we have written that similarly we can prove that these sides are equal and parallel. Then we have taken triangle AOB and BOC to prove that these two sides are equal. Okay, and after completing that the sides are equal, we can write AB is equal to BC is equal to CD is equal to DF. Now why we are doing this? We are taking triangle ABC and triangle BCD to prove that one angle is a right angle. Okay, so we can now write. Now the triangles are congruent by SSS. Now the triangles are congruent, that means angle B will be equal to angle C. And what reason? CPCT. So I can write angle B is equal to angle C, CPCT. If you want, you can write the complete name, that angle ABC is equal to angle BCD. Okay, and the reason is CPCT. Now since these two angles are equal, okay, now I'm rubbing this you've understood what is given. Now children, you know that these two angles are equal. Yes. Now these are parallel lines. So I will write AB is parallel to CD, intersected by the transversal BC. Yeah. Okay. Now because AB is parallel to CD and it is intersected by the transversal BC, then the sum of the interior angles is always equal to 180 degree. So we can write therefore angle B plus angle C is equal to 180 degree. We can name it as co-interior angles, and we can also say that angles lying on the same side of the transversal. Okay, so we write co-interior angles. Okay, we can also write adjacent angles, right? Now I think co-interior angles will be a better option, because you know that two lines, parallel lines intersected by a transversal, they are called co-interior angles. Now angle B and angle C both are equal, as we have proved here. So for angle B I can write, for C I can write B equals to 180 degree. Twice angle B is equal to 180. So angle B is equal to now 90 degree. Yes, very clear. As I told you children, this question is a little lengthy, so maybe I will finish only one question in my video today. Now, this ABCD is a parallelogram. Yes. So in a parallelogram, opposite angles are equal. So angle B will be equal to angle D, that is 90 degree, and angle A is equal to angle C, because C will be equal to B and C will be equal to A. Because C is equal to B, therefore C will be 90 degree. So therefore we can now say that angle A is equal to angle B is equal to angle C is equal to angle D is equal to 90 degree. So now in the end we can write that the quadrilateral ABCD, in which the diagonals bisect each other at right angles and the diagonals are equal in length, it is a square. Okay, sorry, I repeat. We can say that the quadrilateral in which the diagonals are equal in length and the diagonals bisect each other at right angles can be proved as a square. Okay, so in the end you can write the statement that yes, the quadrilateral ABCD is a square, and with all the four sides equal and each angle to be 90 degree. Okay, so you complete this today children. This is now a 20-minute video, and you complete this question, and tomorrow I'll make another video for you. Okay, any doubts you can ask me. Thank you. Have a good day.